Hello, and welcome to the Complete Foundation in Modern PCB Technology, a fundamental technical course from NMT Electronics. My name is Amir Thiab, and I'll be your instructor throughout this course. This course is part of Blueprints of the Future, a series of courses from NMT Electronics that explore 7 key fields shaping the future of modern electronic technology, communications, and beyond. This course will equip you with everything you need to know about printed circuit boards, one of the core technologies enabling the electronic revolution of the 21st century. We'll dive into the generic fundamentals of PCBs, how they're designed and produced, and why they're essential in modern electronics. By the end of this course, you'll have an extensive, practical understanding of PCB technology that will help you in your studies, projects, or professional work. Before we begin the course, let me introduce its outline, scope of content, and learning outcomes. Let's also take a moment to get to know each other. I'm sure you'd like to learn more about NMT Electronics and get familiar with your instructor's profile. Welcome again. Before we dive into the technical content, let's set the stage for what you'll gain from this course. By the end of this course, you'll have a solid, well-rounded understanding of printed circuit boards, how they work, why they matter, and how to work with them confidently in real-world scenarios. First, we will explore the full scope of PCB technology and its applications. This includes understanding where PCBs are used, why they're essential, and how they support the electronics that power our daily lives. Then, we'll dive into PCB structures, learning to identify various board types, layers, materials, and their functional roles. You'll know the difference between single-layer and multi-layer boards, rigid and flexible designs, and why those differences matter. From there, we'll shift into design, equipping you with both the concepts and the tools needed to design professional-grade PCBs. You'll get the essential knowledge needed to work with EDA software, understand design rules, and learn how to create schematics and layouts that are ready for manufacturing. Followed by that, we will go through more foundations needed to master PCB design. This is not a course to teach you how to use any of these software tools in particular, but rather equip you with the common fundamental knowledge that applies in all of them. This will prepare you to use any software of your choice after the course, mastering it later on your own. This course will not zoom into a particular software or field of PCB, leaving these to the following specialization courses. Having mastered the concepts of PCB structure and design, we will next take a close look at how PCBs are prototyped and mass-produced. You'll become familiar with the fabrication process, assembly, and the testing stages, including the necessary quality assurance practices. Finally, we will wrap up the course by zooming out, looking at the economic aspects shaping the global PCB industry, as well as the career paths you can pursue with your new skills. Whether you're here to build a foundation or sharpen your understanding of PCB technology, you're in the right place. You might have been wondering if this course is right for you. Well, if you're a student or a fresh graduate in electrical engineering or any of its branches, such as telecommunications or computer engineering, this course will give you a strong foundation in PCB technology that bridges theory with practical skills. If you are already an engineer, whether in electronics, mechatronics, or even unrelated disciplines, and you're looking to understand how PCBs work and how to design them effectively, you're absolutely in the right course where information is technical, but also simplified. This course is also ideal for electronics repair technicians who want to move beyond component replacement and dive into the structure and design of the boards themselves. Even beyond, if you're involved in project management, product design, or technical procurement, understanding PCB fundamentals will help you make better decisions, communicate more effectively with engineering teams, and navigate technical specs with confidence. After this introduction, the course is organized into 6 comprehensive modules, starting from the very basics, and all the way through the complex technical stuff of design and fabrication, finally concluding with the economical aspects of the PCB industry. We begin with Module 1, where you'll learn what printed circuit boards are, how they've evolved over time, and how they are backbone technology in our modern electronics. In Module 2, we'll explore the physical structure and anatomy of PCBs, covering everything from basic layouts to complex multi-layer configurations, materials used, and how different layers work together on the board. Module 3 is all about PCB design and the tools used to create professional layouts. You'll get familiar with EDA software, understand the general design process, and see how circuits are turned into manufacturable files. Then comes Module 4, where we will take design to the next level. We will cover essential design considerations and rules, advanced layout techniques, and what it takes to meet industry standards for performance, safety, and reliability. In Module 5, we'll walk through the fabrication, assembly, and testing process, from DIY prototyping to large-scale commercial production, including soldering, inspection, automated testing, and quality assurance practices. Finally, Module 6 will conclude the course, focusing on the economics of PCBs, current industry trends, and the career opportunities available in this fast-growing field.